Hello everyone, I'm Saptarshi Mukherjee. I'm a software engineer 3 at Google and a computer programmer. So in this playlist I've been discussing the problems that appeared in Codeforces round 923, the various approaches that we can use to solve them and the solutions, the coding implementations as well. So this is the last video I'm making to wrap up the problems of uh, B, C and D in this contest. I have made separate videos on A, E, F, and G. So I've covered the harder ones. Now I'm making a quick video on these three problems. Let me know if you want any more details, but I'll cover them in short, quickly covering the most important aspects. And also I'll cover the coding implementations. So yeah, let's get started. This first question, question B, there is the second question of the contest. This basically says that we need to recreate a string whose trace is given. What is the trace? It is defined over here. The trace basically is, in place of every character, what is given is how many times that character has occurred before in the string. So for example, for this A occurs twice before this, so 2 is given over here. For this R occurs once before this, so 1 is given over here. We have to form any string. We have to find any string which could have been obtained from this. So one example, it's abracadabra. This is possible to be created from this particular array. Now taking this array, can I form some other string? Let's see. So this is another string that I created. How did I create it? I basically said, okay, for the first 0 I can try an A. For the second 0 I can try a B, because this 0 means I should have not taken this before. I have to choose such a character which I have not taken before, which I have used 0 times before. So I have to choose a new character, and hence I have chosen B. Next 0, C. Next 1, something that I've used before. So something about something within this A, B and C I have to use over here. I have chosen A. So similarly for this 0, I can say I need a new character. So again I have chosen D. Now when it is 2, I need a character for which I have chosen what I have already chosen for 1. So you can see over here it is given somewhere that the trace is valid. For each test case a valid answer exists. That means the trace is valid. So for 2 I am definitely sure that there has to exist a 1 before that. So if you want to find whether a trace is valid or not, this is the thing, that when you are seeing a 2, before that definitely one must have occurred which has not been already matched with another 2 before it. That is the way you can check whether it is valid or not. But over here it is given that it is valid. If you have to check, then it becomes a problem C maybe. Okay, next 0, I am choosing a new character. Then 3, I am choosing the 2 before. If there are multiple 2s, you can basically go sequentially, like I've gone for the 1s. So for 1, I basically gone A, B and C. Similarly for 2, you can go A, B and C in that way. So if I do it from scratch, one strategy I can use is, hey, for zeros, I have not seen anything yet. So I can start with an A. This becomes an A. Then for the next 0, I can see, okay, I've already taken an A. I see that for 0 I've already taken an A. So take B instead of this, go sequentially. So take a B over here. The next one, for the next 0, similarly move ahead, take a C. For the next 1, now go to 1. For this one, go to this 1. You have not taken anything. So take an A over here, and then we can move ahead from the next iteration. Next we see 0, so once again move ahead, it's D. Next we see a 2. 2 is still vacant, so I'm choosing A over here. For 0, once again move ahead. For 3, yes, it is vacant, so choose A. For 1, we can move ahead in 1 from A to B. And again 1, so again move ahead from B to C. Then 4, so it becomes A. So that's it. This becomes your string. This becomes your string. So you need this kind of a lookup table to tell you what is the last character you have chosen for the number. And then you have to move ahead. If you have not chosen anything, you can start with A. Let us see how I have implemented it. It will be that simple a solution. So there's something you have to implement in 5 minutes or so, 4-5 minutes. Definitely good if you can do it faster, like 2-3 minutes. But okay, what have I done here? This is my template. Don't look at the entire thing. uh, so this is where I am. This is the main solution. Integer, this is the lookup table, and then move through it. For each number, we are searching, okay, for this number, what is the last thing we have taken? If there is nothing, then we will take a. It is a minus 1 plus 1, which will result in a. Otherwise, I'm saying whatever is the character, add 1 to it and typecast to character. So that is what I'm going to print. Yeah, this is how your problem B can be solved. Again, how to find out if the trace was valid or not. Like over here, it is given that in each test case a valid answer exists. The question could be that find if a valid answer exists, then print that, otherwise print minus 1. How could we find? We can basically say, hey, uh, for every two, see how many times one has occurred before and two have occurred before. So up to here, if number of twos is greater than equal to, if is greater than number of ones, then that is a problem. Then that is an invalid case. If number of twos is less than equal to the number of ones till now, then it is correct. So at every position you have to check this, that is the count of AI till now greater than or equal to, sorry, is less than or equal to the count of AI minus 1 till now. This simple thing, if you check at every I, that is the check for validity. Okay, let's move ahead to problem C. Problem C tells us that can you choose k by 2 elements from the first array and k by 2 elements from the second array to get all natural numbers from 1 to k. So you can choose half elements from A and half elements from B to get not any k numbers but first k natural numbers. So in A and B, whatever other numbers occur, I don't care. I only care what are the numbers from 1 to k. Other numbers are just disturbances, noise for me. Okay. So this is one example that is given. K is 6, that means I need to see whether I can form this 1, 2, 3, 4, 5, 6 by taking 3 elements from here and 3 elements from here. Can we do this? So if I say that, okay, I'll choose arbitrarily 3 numbers, 2, 3, 5. Over here also I will choose 3 numbers from 1 to k. 1, 3, 5. I'm satisfying k by 2 things. But when I accumulate them, do I get all the k natural numbers? I don't get 6. So I have to choose cleverly so that I don't pick the same thing from both of them. Now, how to check whether it is possible or not? First of all, I can find out how many elements A contains in that range from 1 to k, how many elements B contains, and then if I see that both of them contain at least k by 2, I can see, okay, including both of them, A union B, does it give me all the k? Does it give me k? This is one condition. It must be met. That when I take the union, when I take all of them in a hash set, let's say, all the elements of A and B in a hash set, do I contain all the natural numbers from 1 to k in a hash set? They should contain all the integers from 1 to k. What is my second condition? After this, if I say that A should contain k by 2 elements, at least k by 2 elements, that is greater than equal to k by 2 elements in 1 to k. So I can basically iterate in A and I can say, okay, whatever elements are in 1 to k, keep storing that in a hash set, then finally see how many such elements you have in the hash set, distinct elements. So if A should contain at least k by 2 elements, and if I see that B also contains at least k by 2 elements, Then I'm done. B should contain at least k by 2 elements. If I check these two things, then I'm done. If A contains at least k by 2 elements and B contains at least k by 2 elements, these two are necessary. How does this ensure that I have the answer? By the way, are all the three necessary? If I have the first two, do I need to check the last one? Yes, because it may happen that A only contains everything and B doesn't contain anything. Then that will not help. Then the first two conditions will be satisfied, but the last condition won't be satisfied. Last condition is also equally important, so this is not going to hold. All the three conditions are important. That okay, overall they should contain all the numbers from 1 to k. A should contain at least k by 2 and B should contain at least k by 2. Is this sufficient? Does this give me the guarantee that they contain different sets of k by 2, or they can provide me all the possible k by 2, all possible k, I mean all the possible k natural numbers from 1 to k? This is interesting. So I can say if A contains greater than equal to k by 2 elements, we can visualize this in this set theory manner. This is A intersection 1 comma k. This is B intersection 1 comma k. What is not there inside k? I am just ignoring them. Okay. Now we know that this size basically is k by 2 greater than equal to k by 2. So we can say first of all, we should take all these elements that are only inside A. This should definitely come from A. This should definitely come from A. And this should definitely come from A. This should be chosen from A. And this part that is only in B, this part definitely should come from B. Now, let's say K is something like 10. So maybe 3 elements came from there, 4 elements come from here. Now 3 elements are left. I have the liberty, right? Let's say for example K is equal to 10. Let's say over here I have got um, 3 elements. Over here I have got 4 elements. Now, I know that A intersection B contains 1 to K. It has all the elements from 1 to K. That means this definitely contains all the other elements, the intersection. The other remaining 3 elements. 3 are here, 4 are here. So the remaining 3 elements are there in both. And if they are in both, can I say I have the flexibility? I can take 2 of them in the left half and only 1 in the right half. 2 of them I can take in the left half, 1 in the right half. I have this flexibility. So I can say if I have some k1 count over here, if I have some k2 count over here, k1 and k2 already I have. In between I have k minus k1 plus k2. This I can easily distribute between the two. And how do I know that this will be sufficient? Because I've already checked that A contains at least k by 2 elements in 1 to k. That means this proves that k1, basically my condition 2 is basically proving that k1 plus this thing, k minus k1 plus k2 is greater than equal to k by 2. So definitely however small k1 is, we can include the common elements in k1 and make that at least k by 2. The remaining things go to k2, that will also become at least k by 2. It's not a problem as long as the union contains all, and I have checked these two conditions, that A individually contains at least k by 2 and B individually contains at least k by 2. Then I am not worried. We can definitely balance them. We can definitely assign them, distribute them. So yeah, that's basically what I'm doing over here in my code. If you look at this code, so it's, yeah, what am I doing over here? NMK input, these are the values. Now set 1, set 2 and set. Set 1 and set 2 are basically for A and B respectively. Set is for everything. So I'm basically saying, okay, whatever are there in the first set, if they are less than equal to k, then only they matter to me. Add it in both these sets, set 1 and set. Otherwise, add in set 2 and set. If they are if the elements of the second array, if they are less than equal to k, then add them in the set 2 or set. That's it. Finally, this is my condition, that if the size of set is equal to k and the individual sizes are greater than equal to k by 2. These are the conditions that I've used over there. So if all the three are satisfied, it is yes, otherwise no. That's it. So logically, if you go, it's just these small programs. That's it. For these questions, you just have to go logically. You have to take those 2-3 minutes for thinking without doing any coding. Then you can easily crack the code. Okay, let's move to the last question for this video. Problem D. For problem E, F, and G, please look at the playlist. I've kept separate videos on them. They are really good problems. You'll get to learn a lot of concepts from them. So, coming back to problem D, what it says is this is a range query. So, the array is not being mutated in between. The array contains n integers. We are not changing that. And there are q queries. In each query, we are given L and R. From L to R, we have to find two indices such that their values are different. The values at those positions, those indices are different. So both I and j should lie in that range L to R, and they have different values. Basically, we have to return, I think we have to return yes, no only. Is it? Or we have to return the indices, or we have to return -1 if there are no such indices, right? So we have to basically return, hey, there are two different values. These are the positions where they have different values. Or we have to return -1 saying that there are all the values are same in this range, or this range doesn't have two different values. So you see, such a simple problem. You just have to think in an easy way to crack it. So we are basically saying something like this. We have an array. Nobody is changing the array. We are just getting different queries. And then somebody is asking, hey, from here to here, from this L to R, or on a bigger range, do we have two different numbers? And if so, we have to return such I and j. If there are no such thing, we have to return -1. How do we solve this problem? The first thing that came to my mind is, in this range, if I could know what is the minimum and the maximum. If I could know the minimum and maximum, what can we do? Those are the answers. If the minimum and maximum are same, I am damn sure that in that range, if I know that the minimum and the maximum is same, I know that I have to respond -1. And if they are not the same, then I just return the indices of the maximum and minimum, I and j. I can cover the maximum and j can cover the minimum, right? So this is one possibility. How do I know the minimum and maximum of every range? One way is um, so there are some topics like square root decomposition. I've not used it in the last 2 years, so I won't be talking much into the detail of this. It will be solving in n square root n time, or q square root n, something like that. Square root decomposition. You can take a look at this topic. Um, Another important, so this basically helps in finding min, max, sum, all those things in ranges, different ranges. You can have segment trees. You can have segment trees. Segment trees will tell you the minimum, maximum in any range. You can use in the same segment tree. In the same segment tree, you can maintain the min and max. The updates, etc., will happen their own way. But you can maintain it. You can use two different segment trees as well. Whichever implementation you find easier. Right. What else? Okay, these two are good data structures or slightly strong algorithms. Can I use some easy kind of strategy which we use in our interview preparations as well? We can say, hey, if I just look at this element, this is AI. Let's say this is AL, suppose. If I say that the next greater element, the next greater element is at index, is at index less than equal to R, is at index less than equal to R. For AL, if the next greater element is at index less than equal to R, can I say this proves that there is a different element? How can I find next greater element? We know that for finding this, is a classical problem of stacks. This is a classical problem of stacks. You will find so many tutorials, innumerable tutorials on this. You can find out next greater element at index less than equal to R. What else? If there is no next greater element, that means, does it mean that all the elements are equal? There can be smaller element. There can be smaller element. So if there is if the next smaller element, if the next smaller element is at index less than equal to R, next smaller element, that means from this L, if the next smaller element is at index less than equal to R, then also. So what I'm basically saying is that from L, if I find out the indices of the next greater element and next smaller element, if either of them is within R, I know there is a different thing within R. If both of them are beyond R, that means whatever this is, let me take this as X. That means the first element greater than X is after this. The first element lesser than X is after this. Can I say that means all the others before that margin are X, so all are same. So if none of them, if none of the above, that means minus 1 minus 1. No such pair. Otherwise, we have got that pair. If this index is IDX, I can say it's basically L and IDX. If this index is IDX, I can say that this will be L IDX or IDX L, whatever. Right. So this is the approach that I have coded myself, which I'll be able to show. But if you want simple min max thing, if you don't want those traversal and then I mean this is definitely not a tougher approach. But for this, I mean the segment tree logic might come more intuitively. That hey, this is a range. If I have maximum and minimum, I can solve it directly. It depends on, I mean, which one occurs first. Whichever occurs first, you can use it. So this was a pretty easy problem in that way. Multiple approaches possible to solve it. So yeah. And there is this two pointers. This actually reminds me, there is an algorithm, I think, that is called Mohs algorithm. Right. Long time I haven't uh, really seen this. So you can use this as well. This actually will be a bit difficult to handle. For this problem, probably it will be a bit difficult to handle. But you can intelligently sort the queries in such a way that and that is only occurring because you're not changing this array. If you would have changed this array, then square root decomposition and segment trees would have worked, but Mohs algorithm would not work. But over here, because you're not changing it, you can still use Mohs algorithm. You can use Mohs algorithm. And finally, the approach that I told now is stacks. These are four different approaches you can use to solve this problem. Definitely the easiest one I feel is stacks. So let's look at that code. Yeah. So I basically found this next greater, next smaller. And this is how I do that stack computation. I push the element, and then when I reach some other element, I say, hey, are you greater? Are you greater than that element which is there in the stack? That means you are the next greater element for that element. In this way, we do this computation. I think it will take around 5-10 minutes to explain this. So you can watch it separately later on. Sometime maybe I can take a separate session to explain this. But you'll get many videos on this. You can use it over here directly. You'll find that very important for your interviews as well. this next smaller and next greater element, very widely asked in interviews. Not so much in Google, but in other companies like Amazon, Microsoft, you will find it a lot. See. And then, okay, that's it. What next? For different queries, what am I doing? I'm basically finding, for L, I'm finding the next greater. If I found, I'm printing. The next smaller, if I found, I'm printing. And then if I don't find any of them, or if I basically find them beyond R, both of them, I'm printing -1, -1. That's it. So hope you enjoyed these videos. If you haven't watched other videos, please do go and watch. You might find them interesting, thought-provoking, and helpful going forward. So if you find these videos beneficial, please like, subscribe, and share with folks who might find these as valuable and informative as you have found. So that's it. See you all solving problems and coming back to check editorials. Also, feel free to post comments if you find some better ways of solving it, some different ways of solving it, or if you feel that any of my approaches have overcomplicated it, or probably a part of that could be simplified. Will always be great to actually see all those and evolve accordingly. Okay, so that's it. Uh, Take care, keep coding, keep solving problems, keep solving, keep participating in the later contests, and see you all in my next videos. Goodbye.